All right, welcome to IA 215 week 2. Now we're talking about manufacturing methodology and also project methodology. This is kind of the boring stuff, but it's very important for both team members as well as potential leaders in the development of any kind of manufacturing work cell. So what I want to do is focus on some key terms and focus on uh, educating you guys about the process. And the lean manufacturing has been around a long time. We've already introduced that topic. It's from the 80s primarily, and it's the way that businesses today see, for the most part, a way to continually improve and to continually get better at what they're doing and save money and become better at delivering what their customers need. So it's a very common methodology right now, and I think it's a very good one. This particular presentation was developed by a company called Superfactory, who provided this for free online. And at the beginning of the presentation, there's a whole disclaimer, making sure you know that this isn't meant to be perfect and as is basis, and you're allowed to use it. There's no copyright on it. This particular presentation covers lean in 11 steps. And lean, you're going to find out, isn't this is how you have to do it. Step 1, step 2, step 3, step 4. No, a lean methodology, think of it like a toolkit and a mindset. It's getting people to think about things in their business differently and providing you a toolkit you can use to improve your manufacturing process. Now, some of these toolkits are very common, like value stream mapping. You're going to hear that term used a lot, looking at how you're actually making the product and mapping that process across a tool called the value stream map. That's a very, very common tool. But then all these other ones are very common as well, some a little less common than others, but we're going to go through all of them, and we're going to talk about some of the limitations at the bottom. And frankly, guys, if you don't already know what these terms mean, it's a very useful way to begin to communicate to the management, be able to talk about lean manufacturing, 5S, Kaizen, what all those words mean. This will give you kind of a superpower when communicating with managers who often maybe don't know what's going on the shop floor, but they do know the latest buzzwords. So this should help you there. So let's get into lean manufacturing. What is it? Value in lean manufacturing is the primary driver. It doesn't necessarily mean the dollars input into a product. In fact, sometimes it's the opposite of that. What it means is the value that that product has to a customer, either a next customer down in the manufacturing line, which may be the next manufacturing work cell, or it could be to the end customer. So you have to understand that value is capability provided to a customer at the right time at an appropriate price as defined in each case by the customer. So the customer, that downstream person who's getting that product, has to define the value. And it could be service, product, availability, cost, or performance are all part of value. Waste is another key term in lean. Any activity that consumes a resource, a raw material, your time, but doesn't create value. So there's a lot of waste out there that you simply have no way of removing from the process, but are required based on the nature of how you're setting up your equipment. And so what we want to do is address that waste and see if we can squeeze it out. So what is lean? This is sort of the overall definition of it. It focuses on eliminating waste. It's not about people. It's not about kind of making your process cheaper. It's about making it more valuable for less waste. It can be used to expand capacity. It doesn't always have to be. And it can be used to shorten cycle times. In other words, make your product faster. Those are really common ways of finding waste. And the most important thing of all is understanding what the value that you're producing is, what is important to your customer. So this begins the thinking process. Thinking lean is thinking about the product coming down the production line based on these specific weighed factors. So the ultimate customer in the end is the person who can define value, who can define the value for your product. And the way you develop an understanding of the waste is you identify the value stream. Theoretically, lean also means you're going to be creating flow. Flow means you don't have products sitting in steps, discrete steps with delays in between each step. Flow conceptually means that you're running products smoothly through a facility without batches and without WIP stands for work in process. That means without products sitting there in the middle waiting to be used. And then we're going to let the customer pull production. The idea of pull is very important. The customer makes a demand, and that should trigger the manufacturing process. It shouldn't be that I produce product for inventory and then hope the customer will buy it. It can't always work that way, I know. But the idea is the customer pull creates the demand for manufacturing. And the most important lean thinking concept is you're always improving. You seek a perfection. You're never going to get perfect, but you always keep moving in that direction. So the benefits, I mean, I'm not going to read through the benefits. You can read them. There are a ton of benefits. Cost is maybe the single biggest benefit, but we also get a lot of side benefits. When we're focusing on value to the customer, it could be that we've been doing the wrong things and we're going to make our customers happy if we do slightly different things. It doesn't cost any more money, but suddenly now we're doing slightly different things to make our customers happy. And that could be having to do with the product, having to do with the product packaging, the delivery speed, the timing, the color, the minor variations in the ergonomics of the product. So all these things can be huge benefits purely by focusing on the customer. So a lot of lean came out of Japan. There's a big story about what happened in Japan after World War II. Basically, their economy was completely broken. We helped them rebuild their economy. MacArthur did a lot of stuff right after World War II to help build their economy. There were some people over here in the United States that had some ideas about manufacturing and how you could do it really well. They went over there and helped a little bit. One might argue they may or may not have made a big difference, but in the end, Toyota, the company, came up with a manufacturing approach called Toyota Production System that used a lot of these elements of lean and used them very, very successfully in the 60s and 70s. And then in the 70s, overtook in terms of quality most of the existing car manufacturing lines, whether they were German or American. The Toyota quality was superior, and they proved that they could do this very successfully. And so this is the Toyota Production System. You can read it on your own. They eliminated a lot of waste. They did a lot of just-in-time stuff. That means the part to be installed on that car showed up just when that part was needed and didn't sit around ahead of time. They used pull systems. So they had something called a Kanban system where the part would be laid out and it was used up. A tag would be handed off to somebody, and that tag would say, go order me another part. And then the part would be received and filled up the queue. And your queue would only be as long as it needed to order that new part. So they built in all of these little things: standardized work, robust processes, supplier involvement. They built all this stuff in the 70s and 80s and 90s, and were very successful. So now we're going to start diving into some of the details. We've talked about the big fluffy overview. Let's talk about some of these details. Waste. Waste falls into a lot of category. We're not just talking about, whoops, I made a mistake, I got to throw the part away. That's called a defect. You might have waste that could be excess inventory. I'm paying money to have inventory sit around that I don't need, sitting in the warehouse. If I'm not using it in a manufacturing process and I'm not selling it out of the warehouse, then it's sitting, taking up space in my warehouse and costing me money. It's assets not utilized. It's costing me money. So that's considered waste. And so all these other things as well. Underutilized people. If I have a person that's used only 20% of their time, or maybe used for a task that they are far under, rated for, they could do a lot better. They could do a lot more for you. So underutilized people is a huge asset that if you don't use them, they're a waste. Excess motion, transportation, waiting, all these things are types of waste. So somehow, I guess this is a famous book. The bottom of this slide talks about lean versus traditional manufacturing. The book down there from 1990, the book called The Machine That Changed the World by Womack, Jones, and Roos, is probably the famous book to look up if you're going to learn about lean. And so they came up with these a little bit wild assumptions of lean versus traditional, like half the hours of engineering effort. I don't know about that, but definitely there's some improvements. Half the production development time, I don't know about that. So all these things are a little bit crazy, except for the bottom one, when it says a tenth or less of in-process inventories. And that one I have seen, because in-process inventories is one of the main things you try to eliminate in lean. You don't want a lot of products sitting around half built. So once you get into lean, then you start to see some performance improvements. So these are called metrics. Welcome to the world of metrics. We're going to learn more about metrics later, I promise you. But metrics are a measure that you can actually calculate based on something that's happening in the real world. Metrics are a way of measuring your performance in manufacturing, or your performance in customer schedule attainment, performance in defects. And so these are the kind of improvements we see with lean. 99.9% customer schedule attainment. That certainly is possible. Defects of 15 parts per million, which is extremely low defect rate. And obviously, these are just sort of pie in the sky numbers that some manufacturers have achieved, maybe not all. Operational availability, we keep the line up 82% of the time. Leveling sequenced production, so your production is more efficient, and so on and so on. Now, lean isn't easy for everybody. So this slide talks about those barriers, the barriers to lean. It's difficult for some people because there's that word paradigm. It's not in somebody's paradigm. Paradigm means the current way that somebody is thinking. It's called a paradigm. So people just don't want to think about lean. It's counterintuitive for them. They think, for instance, I can get a cheaper production rate if I buy a really big machine. Buy a big machine, get a higher volume, I'm good. But if you start thinking about lean, that means tuning exactly the volume that you're producing to match your needs. So you may not want a big piece of equipment. You may not want that giant economy of scale. Some people also want to just keep the line running. That's another methodology. Got to keep the line running, even if you're filling inventory up and you don't have anywhere to sell the product you're producing, or products, part numbers that you're producing. So a lot of that methodology, that thinking is keep the line running, make as much as you can, keep pumping it away. You got to keep making product. there is, that's against the lean methodology, but that is a common point of view. This particular slide mentions there is no cookbook. The lean is a set of tools. It's a toolbox. It is not a cookbook. So I won't read through the rest of that. So how do you implement lean? Well, nowadays it's not too hard to gain management support because it is a well-established methodology. Let me pause here for a second to see how many of you guys have already used lean in your business. So some of you have used some portions of lean. Most looks like 5S is the most common. So let's talk about implementing lean. Gain top management buy-in. That should be a no-brainer. Then there's a bunch of things that are more at the project management or plant management level. Perform overall company assessment tied to company strategic operational marketing plans. This team isn't probably going to do that unless you become a plant manager. But these are talking about how you would do a lean, overall lean improvement to a business. However, this course is not about you guys going out there and becoming a Kaizen expert and teaching people how to blitz your business and radically improve the manufacturing processes. No, what we're going to do is just use this general methodology when it comes to the value stream and apply it to a work cell. So all these are good methodology steps, probably not for you, useful to read about and know that they may occur. All right, so the idea behind this slide is all the little things that you can improve as part of your lean. The takeaway for this group is these are all some of those metrics that we might improve. Once we have our new business set up, our new work cell set up with the robot working and doing its thing, these are all lists of things, metrics that we could use potentially measure that improvement. And also the slide says lean is a journey. It is a continuous process. It never quite ends. We just continually try to improve things all the time. It becomes a mindset. So the first tool we're going to talk about is 5S. Obviously, you guys already mostly are familiar with this. It is 5S and visual control. The idea that you, as a technician or as an operator or a maintenance person, should know visually everything where it is should be where it is. And 5S is the process of keeping everything organized.
Hey, Rob, we can't see the screen.
Okay. Let us turn on the screen. All right, so here, you didn't miss anything on the previous screen, but here we are looking at the 5S organizational process. Why is it 5S? Because it's sort, straighten, shine, standardize, and sustain. And I never remember what those S's stand for. I have to always keep a prompt in front of me. It basically means every drawer, every workspace, everywhere you might store a tool or have a part that's useful to you, it needs to be somewhere where you can find it. And you always put it back to that place when you're done with it. And for a lot of people, this means that they buy foam blocks, they stick them in their drawers, and they cut out shapes of their hammers and screwdrivers and stick them in the foam block. So that's sort of the obvious way of doing it, but it can be a lot more complex than that. The idea is you should have enough tools for your team to have the right tool while they need it, when they need it during the workday, and then know where to find it when they are finished. You can come back to that tool efficiently each time. So sort, straighten, shine, standardize, sustain. So why 5S? It should be obvious. I mean, you've got pictures here of, unfortunately, I think I've seen that left-hand picture at a plant nearby here who might make windows. So I'm not going to say anything, but I'm just joking. I don't think they're ever that bad. But when you have a lot of material lying around, whether it be raw material or tools, it creates a real problem in managing that material and finding the right things when you need it. And also there tends to be a huge problem with what I call leakage when it comes to raw materials. Leakage means you never find the raw materials you think you have. It could be because they were broken, destroyed, or thrown away. It could be because they were stolen. It could be because you just had a terrible way of managing it. And so you never really knew where that material was. I think so that's why we do 5S. And I thought we had a picture of a nice 5S setup here. I think the developers of this slide say, well, here's the types of waste we have. And if you go through a 5S process, you're going to find that by having all your material, all your tools lying around in random places, you're going to run into delays with getting something fixed because you had to find a tool. You're going to run into increased transportation time, going and getting these raw materials and loading them up. You might have additional increased inventories. You might have more defective products because your raw materials are damaged, being stacked incorrectly, and so forth. So the 5S way says that for each one of those S's, you get an improvement. And they created this little chart for you. You've got systematic organization, elimination of finding. You don't take time to find something. Eliminate the possible part selection area. You might grab the wrong tool, or you might grab the wrong raw material or the wrong part. And so your deliverable is reduce costs, improve quality. So all those things on the right are just all the good things. But I think you guys can all intuitively understand how, if you have a neat workspace, I mean, this is the ethic from my grandfather that I never seem to have entirely for myself in my own workshop. I tend to let it go a little bit until I do a massive cleanup, and then everything is great. And then I'll let it, yeah. But in a workspace that's part of your business, you can't let it go. You got to stay on top, keep things neat. So here we see those wastes. What are the wastes to be identified in the photo? Obviously, you see misstacked materials. And the idea is after 5S, you should have clear, shiny aisles, color-coded areas, slogans and banners, no WIP, no half-finished material sitting in the manufacturing line. Everything running through smoothly. I'm not sure how slogans and banners, maybe morale. I'm not sure how slogans and banners fits in, but that is often included in 5S. A clean factory that's well laid out does tend to make people happier. All right, so we're going to skip through a couple of these slides as less important for our purposes. For instance, a common thing in a normal lean manufacturing process is workplace observation. We're going to kind of quickly go through some of these things of sorting out your parts, straightening lines, labels, and signs, shining, standardizing, and sustaining. I will say a little bit about sustaining, and that's the part that I fall short on in my own personal workspace. Make sure that all the people who use that space are trained to use it properly. If a raw material or if a part or a tool is no longer needed, you remove it from your 5S and add in new parts when they are needed, to replace those old tools. So you have to make sure you continually improve your 5S arrangements. You have to make sure you've got, kind of a weekly and a daily view of it. So every day you do a little bit, and every week you do a little bit more, a larger 5S. This has to be driven by the plant manager. Now, the reason why I say it's pertinent to us doing work cells is because that long-term sustaining is a key part of building your work cell. You have to have built into your work cell process training for the operators who can then make sure the new operators get trained. So you have to build a training package that has legs. You can't rely on the one or two operators you train first to train the next two. You got to make sure you've got a process in place for continuous support of new operators and new programmers to do adjustment of work cell, robot points and new PLC. People understand how that PLC program works and make sure your documentation is good so that if a person needs to go in there and change something, they can find that change location very quickly and make the change without at risk of screwing something else in that system. So we're going to learn about the sustaining of a work cell following the basic lean methodology. So the last area is this whole visual factory thing. Make it pretty, mark everything off. Like I said, less so that 5S, I think, for our particular project. We are going to talk about Kaizen. Kaizen is the #1 tool for a fast change. Kaizen. Kai means good, Zen means, I'm sorry, Kai is change, Zen is good. So Kaizen is a common manufacturing improvement process. It is essentially very similar to the agile in terms of approach, and it's always based on the customer's needs. Kaizen is a business or process improvement methodology. And the Kaizen process identifies in its plan the current state. This is the value stream, what our previous book called the manual value stream, where you've got a person doing the job instead of a robot, and the future state, that would be the robotic value stream, and that's the future state, and then come up with a plan to get from A to B. Do, check, act, and repeat. And that's where Kaizen works really well with the Agile methodologies. Agile has these little methodology, and we're going to get into that a little bit later. Agile methodology has this sort of very fast cycle improvements to a software package or a work cell. And so we're going to talk about how that meshes in with the traditional lean Kaizen process. And the first step is always to identify the customer. We have to identify the customer. Who is the end customer and what do they see as valuable in that product? So we're back to the types of waste. So the first step in lean manufacturing is to clearly document, not identify the current state. You could say, there's the current state. That's the way it is right now. That's not enough. You've got to document it. You've got to clearly document the process. It is current state documentation is very important because also we want to make sure we didn't lose anything that was being done. We slap a robot system without currently understanding what they're doing right now, we may not get the robot system we want to get. So you got to identify the current state. All these things are part of the current state, and we're going to learn about them as part of our methodology. We have to identify the value added and non-value added, but it might be required. We have to do that step just to let that product keep moving down. But then the one we're really going to attack is the non-value added, non-required. That's NVA without the R. That's what we want to really find and eliminate. And the current state process is usually more questions than answers. Now, the Kaizen uses the brainstorming approach. Brainstorming, if you're not familiar with it, means you gather a team together in a room, but the team makeup has to be really important. It has to be people who know a lot about the process, who are willing to share what they know, and who are willing to listen to other people in the room. Willing to share, willing to listen. And if you find somebody in that brainstorming process who isn't willing to share, they're not providing any value. If you find someone who's not willing to listen, they might provide some value, but they may block any improvement because they just don't see that that's possible. So you want to get a group of people together that's going to throw out ideas and not be too much locked into the way things have to be. So it is a brainstorming process. They brainstorm on the workflow, the technology, the people, the procedures, everything is open to it. The objective with these brainstorming is to identify what's called a Kaizen burst. A burst, and we go through the Kaizen process later on when we talk about value streams, that's basically where you draw your map out, your current state process out, and then you say, wow, why are we doing that step? We used to do that step in 1967, but we haven't really had to do that step since they changed some regulation in 1989. Why are we still spending those extra 30 minutes and extra product parts on that step? And everyone looks at each other. So I don't know. There's no reason. Bam, you throw a burst on there. That means you show a little jig-jag kind of cloud. Put a note in there saying, yes, we might be able to eliminate this particular process step. So you develop an implementation plan and you execute. And then you communicate. It has to be well communicated. The most important thing is when you have a work cell, you have any kind of process improvement, you've got to get the support of, number one, the bosses. They have to be behind you. That's absolutely required. Number two, you need the operators on the line to support you. Sometimes that's hard if you're putting a robot in, but it's critical because if you don't get the support of the operators around that robot cell, it probably won't do well. We call those team members. And third, you need the support of customers. The people who use the parts downstream and the end customer, they have to be willing to support this process and see that it's valuable. And you have to publicly track how you do and celebrate small victories, because sometimes that's all the victory you get. So let's talk about the final step, which is check and sustain. We talked about metrics earlier. I said I can improve my throughput rate or I can save my waste. You have to keep measuring these improvements to make sure you get them. Sometimes if you start making a process change, you find that the improvement you think you're going to get is not the improvement you're getting, and you need to be able to adjust to get the improvements that you thought you could get. So we put our improvements out on a board, we stick them on a bulletin board, we stick them up on a screen somewhere, and we let everybody know how we're moving forward. And readjust and sustain means keep checking and keep tweaking. Okay, so we're going to kind of skip over the blitz because it's not appropriate to a work cell. A blitz is just a very fast project. It's usually associated with a change in one particular production line, one narrow area. And they talk about a 5-day process improvement. That's not what we're about with the work cell. It takes longer than that to just put a robot on order. So we're probably not going to use the blitz process. But we are going to use value streams. But before I dive into value streams, let me pause here and see if we have any questions. Okay, so let's go on. Let's talk about value streams. We're going to identify them. We're going to talk about the mapping process. We've got the current and future state. And we're going to talk about making the change. And a little bit about roadblocks to value stream mapping. A value stream is a set of all actions required to bring a product or service from raw or some other part to the customer. So that's the definition of a value stream. And they give you several examples of kinds of value streams. We don't care about anything except for the manufacturing version. So the starting point for any value stream is to talk about what is the value. What value are you creating? And then you can focus on where something you're doing isn't directly creating value, and that's how you define waste. So put on your waste glasses. So the reason why we're doing this, it helps you visualize process. It really helps in visualization. You can look at a process, you can write about a process, but the value stream mapping is a visual way of putting that process down to paper and then collecting the key data associated with that process all in one space. And it becomes a way that manager down through the shop floor guy can all look at the process and communicate equally about it. It's a common language. I'm going to skip through that little fluffy bit. So the current state. Do all these things to figure out the current state. Document customer information, do a walkthrough, fill in data boxes, very generic stuff. We're going to go through samples of that. You also need to see where are inventories coming into and flowing out of physically that current state, how things are right now for your production line. And they give you a hint. Try to distinguish buffer stocks, safety stock, and shipping stocks. And ask questions. So we're going to kind of fly through this current state stuff to the example. This is an example of a value stream map. And one of the videos I provided does a great job of talking about each one of these things in that particular value stream map. The important part as we look at this map is we see across the bottom, at the very bottom, you see durations. It above each one of these little dips, which measures seconds, minutes, or days, or hours, you're going to see a box that describes a production step. Stamping, welding, assembly, shipping. So these are pretty generic production steps. And for each one of those steps, you're going to see kind of some details about how long it takes, how efficient, how much uptime that machine has, how many shifts are running, and how much total available time there is for that particular operation. And you're going to see little eyes in there for inventory. And the inventory should show you that there is inventory moving from step to step to step. It shows you product being delivered on the right side to a different assembly plant. So that's your customer in this particular product. So this map, this is a classic value stream map. It shows you how you're making that product, not in kind of how it's assembled, but the steps required and how long each step takes to produce that product, and then where those inventories are in between those steps. So typically, for somebody who's brand new to the whole lean process, the first time they do a value stream map, they see that 80% or more of the amount of time for a product to run through that plant is considered waste from the point of the end customer. They don't care about inventory sitting around between steps. You add nothing for that, right? What they want is a product efficiently run through. They don't care about anything but whether that product works or not. And you also see that nearly 100% of throughput time is wasted time. So what's the effect of that current state? If demand becomes erratic, it creates problems with inventory, capacity, and costs. Quality becomes worse. and there's a lot of issues with that. So that's pretty much typical. So developing the future state is where the brainstorming comes in, and here we talk about how they would want you to do that. And here we can see how that particular team came up with their future state. They took out the extra welding, and they changed the process to go from a stamping to a combined welding assembly work cell. And they took out all those places where inventory was being stored in between all of those workstations. So now their total production lead time is only 4.5 days. That's on the bottom right here, 4.5 days. And they're going on a daily truck straight to their state assembly plant. So they cut out a huge amount of steps and also probably a lot of costs. So of course you want to implement your change. Critical success factors, we talked about this, management needs behind you. This is kind of a repetitious presentation. So to do this successfully, you need a value stream manager. You need a project manager focused on that continuous improvement, who reports up to pretty much the plant manager. So here they're talking about typical change. We already went through that. Everything gets better. But now let's talk about roadblocks. The biggest roadblock of all is old process thinking, that paradigm, that thing that, hey, if my grandfather thought this was a great way to make this product, then it's probably good enough for me. That sort of old habit is not conducive to improvement. So the idea is you want to get around that bad habit, 75 years of bad habit. You also have a problem with financial focus. If someone is purely saying, all right, I got to get a 5-year payback to this solution, and I don't see how that's going to work for you guys, you might have a problem, because there could be a whole lot of under the cover improvements that will definitely get you your payback, but you can't prove it with the clear performance metrics. So you may have trouble with your finance person. If you have an accountant in your plant, you got your plant controller. He's going to say, no, I must see a 3-year improvement, payback in 3 years. So we're going to talk about how to get around that. We're going to skip some of these other rollbacks here. So another key approach is pull manufacturing. And for pull manufacturing, the idea is that you only produce inventory or produce a part when it's needed. And you only store enough inventory to allow for the cycle time from when you know you need it to when you get it. So it basically reduces your inventory. It's a huge, why do pull manufacturing reduce inventory? The problem with scheduling parts to be produced is stuff changes. You might have rise in demand or a drop in demand. And if you do scheduling, that's called push, produce the part that you're scheduled to produce, a lot of times you're going to create excessive inventory, or you might run out. If you have got pull scheduled, then you only produce as fast as you're consuming the parts. So then they've got this whole thing in here. Excess inventory hides the fact that you've got a bad manufacturing process. If you reduce your inventory, your WIP, then you start to see where you've got problems very, very clearly. So just in time is a whole concept that came out of Japan. The idea that the parts only show up when they're needed. And believe me, I've seen this in operation very, very successfully. A great example is in Harley-Davidson in York. They have got a system there where they've got a giant warehouse with a whole bunch of trucks constantly pulling in, a small staging area, and then a bunch of little carts that zoom away from the staging area and deliver parts to the line, to the production line where they're doing assembly of these motorcycles just before they're actually needed. So they're constantly receiving, loading up a little cart, and keeping that line running with parts. And the suppliers are sending their trucks in so they arrive precisely at the time when they're needed. So obviously the objective of just in time is the right part at the right time at the right quality. So JIT principles, just-in-time principles, it talks about one-piece flow, the idea that you should only think about the parts as one piece at a time. And that's really important for discrete manufacturing environment where you're making automobiles or cars or toasters or all sorts of things. You want the parts to go through and be delivered on a continuous basis. You don't want to queue them up, have a batch of parts there. You want them continually being improved one piece at a time. So quality, I'm not sure I agree with this. You guys think that quality enables JIT. It's partially true. So we're going to skip through the JIT a little bit. The Kanban is a flow process. It's sort of that pull flow as expressed in Japanese. The word Kanban means card. It's a very important term to know. And the idea was that you'd have a little row, a little stack of inventory set up so that when somebody used one of those components out of inventory, every few components, you'd have a card. So if you use the component up to that card, you need to take that card and hand it to somebody or drop it in a vacuum tube and have it sent over to the department who makes those parts. And then they would kick off a process to restock your Kanban. That means you're only producing enough at the rate you need for when you need it. Maybe a couple extra just to handle the additional time it would take to send that card down and get those parts over. A lot of manufacturing sites, especially the manual ones, are set up in called Kanban squares, where somebody's working on a product at a workbench, they drop it into a square. When they're done, when the next guy needs it, he pulls it out of the square, and then it triggers you to drop your part you're working on back into that square. I'm not sure it works as well as all that. It's definitely not what we're going to do with robots, but that was a Kanban process. That's okay. We're going to skip over a bunch of the one-piece flow Kanban stuff here. And we're going to get down to standardized work. There's a couple of key terms in here that we're going to have to remember. Takt time, that's T-A-K-T, takt time. That's the time to produce a part or finished product with the rate of sales. It's the basis for determining workforce size and work allocation. So takt time is how many minutes it takes you to produce that part, or hours or days. We want to standardize the work with in-process inventory, standard in-process inventory, and we want a standard work sequence. That's going to be critical even for our work cells, because we want to have that work cell be consistent and each operator trained to support that work cell in exactly the same way. But why would you have a robot? Because the robot also is going to be absolutely consistent. It's going to do it the same exact way each time. So takt time is the rate at which customers require your product. It is available work time per day divided by the daily required customer demand in parts per day. And so the idea is you want to do some smoothing or leveling so that you can basically set up your manufacturing line to continually produce at the right rate for the customers that demand your parts. So let's skip over the rest of the smoothing leveling because it's not important for our work cells. But what is important for work cells is another tool, mistake proofing. And actually for the robotic work cells, mistake proofing is something else. If you guys remember from your first robotics class, one thing that's very important is designing fixtures and grippers so that if the robot is slightly off or the part being picked up is slightly mismanufactured, the robot can still pick it up successfully because you've developed a gripper that allows for a slight misalignment, or you develop a fixture that self-centers the part when you put it into. So that mistake proofing is very, very important in a robotic work cell. It's also important for almost any manufacturing process. So let's skip through most of this. Just remember that word, poka-yoke, avoiding inadvertent errors. I'm sorry, I think it's pronounced poka-yoke. Let me give you examples of that. So let's skip through some of the examples they give. Since our mistake proofing is pretty much focused on the robot. It should be our approach to all robot systems that we constantly poka-yoke. And actually, outside of our work cells, the use of sensors to make sure a part's in the right position is very good. You basically have a nice living from that, doing that for companies. Putting sensors in for the poka-yoke to reduce the chance that the part will be in the wrong spot, or the hole will be wrong spot in the part, or it'll be aligned incorrectly when you do your work on it. We're going to skip through most of this. All right, we're going to skip through quick changeover. And then we're going to drop into something called Six Sigma. Six Sigma is another tool in the lean toolbox. Now, Six Sigma had its own sort of beginning and end and so forth. But I think, though, for the purposes of this lecture, I'm not going to take you through Six Sigma in this presentation. Instead, what I'm going to do is direct you to the next presentation. We're going to skip through the Six Sigma here. And we're going to do it on the next presentation. In fact, I think that we've pretty much, let me pause here. I think we're pretty much through the presentation, all the key parts that I wanted to go through. So let's pause the work here. So I think we've hit on all the components in this slide. It's a very big slide set. I think we've hit on all the ones that are important for this class. The key ones are 5S, the whole process of Kaizen, which includes value stream mapping. Value stream mapping is very, very important. We did learn a little bit about metrics in that, and then we're going to learn and do value stream mapping as part of this whole process. But I think that is mostly the toolkit we're going to use out of the lean manufacturing process. You, of course, are welcome to read through the rest of these slides if you have an interest in ever becoming management and getting involved in your plant's lean processes.